Today we are going to discuss about rational numbers. Rational number. It's a number that can be expressed as the quotient or fraction p upon q of two integers, and that integer can be positive or can be negative. Now a numerator p and a non-zero denominator q. Since q should not be zero because the fraction will be undefined. Therefore, q should be equal to 1, or we can say greater than 0. Then every integer is a, if it fulfills this way, then every integer is a rational number. Now, look the spelling of rational, R-A-T-I-O. And if you separate R-A-T-I-O from rational, it is a ratio. So the first point, let us discuss few points to understand a rational number. Here, the ratio between two numbers, p is equals to 1 and q is equals to 5, we can represent as 1 upon 5. They both are the two positive integers. Clear? Now second, every integer, positive, negative or 0, can be written as p upon q, where q is equals to 1 and not 0. Clear? Now about positive. If its numerator and denominator are either positive, both positive integers or both negative integers, then we can say it's a positive rational number. How? We will see it in the next page. Take example, p is to q is 1 upon 1 is to 3. We can write as 1 upon 3. That is a positive rational number. Now both the ends, numerator and the denominator, both are having the minus sign. Then these minus will be cancelled, or you can say it will be multiplied -1 on the numerator and -1 in the denominator, and that will turn into positive. Clear? So they even they are having positive numerator and denominator, or if they are having negative numerator and denominator, then also the rational number is positive. Clear? Now for the negative, when its numerator or denominator are negative integers, now p is to minus q, we can write as p upon minus q. And if we take assign the values to them, then 1 is to minus 3, we can represent as 1 upon minus 3. Or if in the numerator part is minus here minus p is to q is equals to minus p upon q, where if we assign the value, which we have already did for the first example, like here -1 is to 3, we can write as a minus 1 upon 3. Now here they both are the negative rational numbers. Clear? Because I try to do it first for the denominator part and then for the numerator part, separated it. Now for the 0. Now p is to q, where p is 1 and q is 0. If we take it, then 1 upon 0 will give you not defined, which way the value you can never define it. Now p is to q, if we take it 0 on the numerator side and 1 in the denominator side, which is greater than 0, then yes, 0 will be coming, and 0 is a rational number. Now every fraction is a rational number. P is to q can be written, and if you assign a value to them, 1 upon 3, it is a fraction form and it's a rational number. Now every rational number is not a fraction, because fraction do not contain the negatives. Now here if you try to put in the denominator part minus, then it's not a fraction form. Clear? Now point number 4. All the terminating decimal numbers are rational number. This you must have studied, that while dividing, if you are getting the answer, so they are in the terminating form. But when you are dividing some terms, especially not perfect squares, then the division will go too long and you cannot turn into fraction form. So non-terminating is basically an irrational number. Clear? And terminating decimals are the rational numbers. Now here 0.5 can be we can represent as 5 upon 10. Now 5 upon 10, if we try to divide it with a 5, it will come 1 upon 2, and that is a rational number, isn't it? Another example, that is 1.6. We can write it like 16 upon 10 as well. Now here divided by 2 on the numerator and the denominator part, the answer is 8 upon 5, which is still a rational number, positive rational number. Now all the non-terminating numbers are irrational numbers. Now the here square root, uh, here the under root 3, under root 2, they are the imperfect roots, because as I have calculated the value, see how far the numbers are going, and still it can be going. It is not the end only. 1 point, now the under root 3, the value is 1.73205080756888772935 and so on. So it is difficult to make them in a fraction form. Clear? Same way with the under root 2. The here the square root of 2. Here 1.414213562237. Difficult to make it in the fraction form, so that is why they are the irrational numbers. One more thing, to represent a rational number, it is generally the acceptance sign is q, and to assign this irrational number, it is q dash generally. All right. Now equivalent rational number. Two or more rational numbers are called equivalent rational number if they have the same value. Now, the basic property of rational number. The value of a rational number does not change if both the numerator and denominator of a rational number are multiplied by the same non-zero integer or divided by the same non-zero integer. Let's understand with this that you have already studied in the fraction that any number, if you are multiplying on the numerator and denominator part, it does not change the fraction. Any number, you try to take any number and divide it in the both numerator and denominator, it does not change the fraction with the same way, but it should not be with 0. All right, it should be greater than 0, non-zero. So the rational number property is also having the same thing. You have to multiply. If you multiply with the same, it does not change. If you divide it by the same, the numerator and denominator part except zeros, so it won't be changed. Now here example is there, p is to q is equals to 8 is to 6. Now p upon q is equals to 8 upon 6. We can further simplify it to make it in a standard form, simplest form. So divide it with 2, then it is 4 upon 3. All right, 4 upon 3. Now if 4 upon 3 is multiplied with 2, now here it was the division, it was not affected, the term was not affected. Now again I did to multiply to give you, to show you that division and multiplication does not make any changes in the rational number. Now here I have multiplied with 2, now it comes once again 8 upon 6, no change was there. Clear with this? With one example, two properties are discussed. Now test for equality of the two rational numbers. Now P upon Q and R upon S are equals. So P upon Q is equals to R upon S. What do we have to do here? We have to use the cross product rule, which is the cross multiplication rule. So P into S and Q into R. If both sides LHS and RHS are same, it means that yes, they are equal. Now, for example, if I take 1 upon 3 and 3 is to 6, all right, two different rational numbers. Let us see whether they are equal or not. Now 1 upon 2 is equals to 3 upon 6. Do the cross product rule and do the cross multiplication. Now 1 into 6 and here 2 into 3, that is 6 is equals to 6. LHS and RHS are same. It means that yes, these two are equal. Clear? Now about standard form of a rational number, or we can say is simplest form. If its denominator is positive and the numerator and the denominators have no common factor other than 1. Clear? Now denominator as positive. So first thing you have to make the denominator positive. If it here it is p is 2 minus q. Now p upon minus q, we will be multiplying minus 1 on both the end. So it will turn minus p upon q. Now simplify the numerator and denominator with same kind so that the no common factor other than 1 is left. Now here 16 is to 24. What I did is that either you take the SCF part or do this way. Try to take 16 LCM and write it over there. Then for 24 LCM, write it over there. Do the cancellation part, which are having same in the numerator and denominator, cancel it, and whatever is left is there. All right. Or you can take you can find the HCF of the both the numbers and divide it and make it minimum. Clear? In the both the ways, the answer is 2 is to 2 upon 3. Clear? Now representation of number rational numbers on number line. This I have already discussed in detail in the integer part. Once again, it will be a revision for you to understand it. Now here, the side which is the positive side is on the right side. We say it in the ascending order: 1, after that 2, then 3, then 4, then 5. Now the side which is a negative side, that is the left side, which is in the decreasing order, means minus 1 is bigger than minus 2, then minus 2 is bigger than minus 3, minus 3 is bigger than minus 4, and so on. Clear? Now how to represent these rational numbers on number line. Now represent 4 upon 5, 5 upon 2, minus 1 upon 3, and minus 9 upon 4. In order to do such type of representation on number line, you should try to make it into a mixed form, and that will be more easy for you to do it then. Now here 4 upon 5, you cannot do this as in a mixed form. Now, but 5 upon 2, yes, you can do it, which will be 2 and half. All right. Now 1 upon 3 you can't do, but yes, 9 upon 4 you can do, 2 1 by 4th. Now how to represent? Now on your screen you can see 0 is at the middle point. 0 is at the middle, and the side which is towards the right side is having the positive, and the side which is having the left side is having the negative. Now first mark it 4 upon 5. Now here 4 upon 5 is less than 1. Remember this. Now from point 0 to 1, divide them in 5 equal columns. All right, divide it into 5 equal parts, and where the fourth part will come, that will be 4 upon 5. Very simple to do it. Now take 2 half. So 2 1 by 2. So for that, it is greater than 2 but less than 3. So you know the position that where it should be 2 in between 2 and 3. Now half. So half, you try to as you can see that it is very simple for you to draw this 2.5. Clear? Now for 1 minus 1 upon 3. Now see how to do it. As you know that this is also having less than 1, because if you divide it, it will be coming 0.66 and something 0.33. Now so it is less than. Now the line starting, it is in the negative side, you have to come first on the negative side. So from -1 to 0, divide into 3 lines. All right, 3. And the first one, because it is you have already studied fraction. All right, so you know how to make it. Is a fraction form. Out of 3, 1 is there, so 1 upon 3 we write it in the fraction form. So here also in the number line, where one 3 compartment, you have to divide into 3 parts, and the first part will be 1 upon 3 in the minus side of 0, I mean to the negative side. Now for minus 2, 1 upon 4. Now here it is greater than 2 but less than -3. And here 1 by 4 means you have to, from -2 to -3, you try to divide equally the part into 4 equal parts. You have to divide it, and the first part, that over there, it will be -2 upon 1 by 4. Clear? I hope it has been well explained for you to understand it. Now, absolute value of a rational number, this a sign in which it is in the blocks form, as I have already discussed in the first chapter. The absolute value of a rational number is always non-negative. Even the negatives will turn into positive, and positive will remain the same. Now here a upon b within the these half box, or we can say that half sign, this sign is there. So we can, even the minus numerator or minus denominator will be the positive. It is just to implies to show is that the absolute values should always be non-negative. It is there. A comparison of a rational number, take two rational numbers, that is a -1 upon 2 and -3 upon 5. So to compare, we have to make it into a like fraction form. We have to make the denominator same. So take the LCM for it, 2 and 5, which is in the denominator end of both the rational numbers, and that will turn into, if you calculate, the LCM will be 10. Now here 10 in do and try to, now in the table of 2, 10 comes 5 times, multiply with the numerator part, that is -1, that is -5 will be coming, and on the another, and then in the table of 5, 10 comes 2 times, multiply with -3, that is -6. Now here -5 and -6 came. Now separate it, then -5 upon 10 is greater than -6 upon 10, because it's a minus. All right, don't get confused that -6 is smaller than -6. It's a negative. So the term which is, or the figure which is close to the 0 are the is the biggest one. So -5 is close to the 0, so it is bigger than -6. Now basic operations on rational numbers. Addition. Rational number having same denominator, that is P upon Q and R upon Q, where Q is greater than 0. So Q will be is the same over here, so P plus R. Or take with the figure, it will be easy for you if I take it as a numbers. So half and 3 upon 2, and then 2 is having the same if we take the LCM also. So 1 plus 3, that is 4. 4 upon 2, simplify it, you will be getting 2 as the answer. And here, if it is not been in the simplest form, that is P plus R upon Q. Now a rational number having different denominators. Now here, if the denominators are different also, you have to take the LCM part. Now here P and Q are the two separate terms. P upon Q and R upon S. They are the two separate rational numbers where Q and S are not same, and they are greater than 0 as well. So here QS, if we take as a LCM, then P Q is the same, so S will be there and S into P, and over here S is the same, so Q is taken RQ. This is the way, or you can take as if you are taking the term half and 3 by 3 upon 2 upon 3. So two different denominators of the two different rational numbers. You just take a LCM of 2 and 3, that is 6. Here in the table of 2, 6 come 3 times, so 3 into 1 is 3, and here in the table of 3, 6 comes 2 times, so 2 into 2 is 4, so 3 plus 4 is 6, so 7 3 plus 4 is 7, so 7 upon 6, or you can make it into a mixed form, 1 by 6. Clear? Now additive inverse of a rational number. You have already studied. See, to understand this topic you have to go on the first chapter and to understand it very good, or you have to understand it well to get these things, because these all are mentioned in the first chapter. So P upon Q minus P upon Q. Now what do you think will be the answer? The same number minus with the same number, the result will be 0. How? Take the common fact, take the LCM for it, and Q is the same. Now P minus P will give you 0, and 0 upon Q gives you 0, the value. Now minus is there within the now minus is outside the braces, and minus P upon Q is there inside the braces. Now when the moment you open this block, you have already studied that minus into minus turns positive, so here P upon Q will be in the positive form. Now addition. Now minus half plus 3 by 4. So minus half and 3 by 4, take the LCM of 2 and 4, that is 4, and 2 in the table of 2, 4 comes 2 times, multiply it in the numerator part, that is minus 1 into 2, that is minus 2, and here 4 in the table of 4, 4 comes 1 time, multiply with the numerator, that is 1 into 3, that is 3, so here minus 2 plus 3 will give you 1 upon 4. Clear? This is the simple addition. Now subtraction. P and Q and R upon S are the two rational numbers. Then P upon Q minus R upon S we will be taking as an LCM for it, QS, and then PS minus RQ. Now let's take over with the number 2 upon 3 minus within the braces minus 1 by 4. Now as soon as we can also write as 2 upon 3 plus additive inverse, we have already studied, plus additive inverse of minus 4, that will turn into positive only, means 2 by 3 plus 1 by 4, as seen as 2 upon 3 plus 1 by 4. So we take the LCM of 3 and 4, that is 12, and then in the table of 3, 12 come 4 times, 4 multiplied with the numerator, that is 2, it will give you 8, and here in the table of 4, 12 comes 3 times, 3 into 1, it will give you 3, so 8 plus 3 is 11, 11 by 12 upon 12 will be the answer. Now we will discuss about the multiplication. P upon Q and R upon S are the two rational numbers. Then it is the most simplest way to understand, just simply multiply to the each numerator to the numerator and denominator into denominator, and PR upon QS. Now 1/2 into 3 by 5, we just simply multiply it, then the answer will be coming 3 upon 10. When a rational number is multiplied by 0, the product is always 0. This you have already studied in the property of 0 in class 3rd. Any number multiplied with 0 will give you 0 only. The reciprocal of a rational number. Two non-zero rational numbers are called reciprocal of one another if their product is 1. Alright, now P upon Q is the reciprocal of Q upon P, where the denominator will turns into numerator and numerator will turns into denominator, and if they will be cancelled each other and the product will be 1 only. So the reciprocal of a rational number is called its multiplicative inverse as well, we say it. Alright, and the reciprocal of 0 is not defined. No number can divide 0. That is why it is for reciprocal of 0 still it is not defined. So the reciprocal of the reciprocal of a non-zero rational number is the number itself. Now how to understand it better? Now P upon Q, the reciprocal will be Q upon P. Now the reciprocal of Q upon P will once again will turn into P upon Q, and P upon Q are same. This is what it is written. The reciprocal of the reciprocal of a rational number is the number itself, the same number, no change. Clear? Now for the division, P upon Q and R upon S, where Q and S should be greater than 0, or we can say non-zero, are the two rational numbers. Then here P upon Q divided by R upon S, P upon Q can be written as, can be flipped and can be written as S upon R. The denominator part turns into numerator and the numerator part turns into denominator, and then simply do multiplication. So in division this multiplication is also there. Clear? Let us discuss a few questions to understand what we have discussed till now. Okay, now the first, which of the following are positive or non or negative rational number? The few numbers are given here: minus 2 upon 3, 3 upon minus 4, minus 2 upon minus 5, 0 upon minus 3, and 2 upon 7. Now you have to find out the positive numbers and negative numbers from it. The positive numbers here will be minus 2 upon minus 5, because here if you multiply both the end with minus 1, they will turn into 2 upon 5. Alright, and they are the positive term. Or, and the second number is 2 upon 7, because it is having the positive sign. So these two numbers are positive. Now negative, now here minus 2 upon 3 and minus and 3 upon minus 4, they both are negative rational numbers. Now what will happen with 0 upon minus 3? It is neither a positive rational number nor negative rational number, because 0, if 0 upon minus 3 will give you 0 only, and 0 is neither positive nor negative. Clear? Now write 5 equivalent rational number to 3 upon minus 7. So now here what it is the best way to do it, that 1 2 3 4, do it with this way. Try to multiply both the numbers with 1, so you will be getting the same, that is 3 upon minus 1. Then multiply 2 with both numerator and denominator side, that will give you 6 upon a minus 14. Then with 3 multiply it, you will be getting 9 upon minus 21. With 4, if you multiply 12 upon a minus 28. With 5 you are getting 5 upon minus 35. So these are the 5 equivalent. Now why I'm saying equivalent, because if you try to make them in the simplest form, they all will be coming minus 3 upon 7 only. Clear? Now write a 3 upon minus 10 into positive denominator number. What we have to do, we have to multiply -1 on both the end, I mean numerator and denominator. So the positive numerator will turns into negative numerator, and the negative denominator will turns into positive denominator. We express 6 upon -7 as a rational number with denominator 35 and numerator -6. What we have to do in this equation, not in equation, in this rational number, we have to make the denominator 35, positive 35. What in the table of 7, 35 comes 5 times. So but if you multiply with 5, it will be -35. So you have to multiply with -5, then only you will be getting positive 35. So you have to multiply with a -5 on both numerator and denominator. Then the numerator will change into -30 upon 35. This what was been asked to do it. Now for you can do it for the numerator side. Now here it is asked -6, and in the expression it is there, 6 is already there. So how you can convert 6 into -6? Just simply -1 multiply with -1, it will positive will turn into negative. So here -1 will be multiplied on both the numerator and denominator part, and -6 upon 7. Clear? Now question number 5. Do the following pair represent the same rational number? 5 upon 25 is a one rational number, and 45 upon -75. Now make it into a simpler form, both the rational numbers, and the first one divide by 5, that will come 3 upon 5, and the second one with 15, that will come 3 upon -5. Now here 3 upon 5 and 3 upon -5, are they same? No, because of minus the denominator of an other rational number is minus, so they are not the same. If it would have been positive, yes, they would be same. Now write the following number in a standard form. What, as I have discussed, that you can do this way as I have done in the rough work. 195, you try to take the LCM of this, try to write it over there, or you can do the SCF part, try to take out the SCF of the both common, and uh, then divide it. So here it will be easy for you to do it, and the error will also be very less. Now here minus and minus will be cancelled, or you simply multiply both the end with -1, so that part will be turned into positive. Now 195, if it is there, 3 into 5 into 13 will give you 195, and for 520 it will be 2 into 2 into 2 into 5 into 13. Now cancel. What is left is 3 on the numerator part, and what is left in the denominator, that is 8, mean 3 times 2. So that is the answer, 3 upon 8. Now question number 7. Now the point P, Q, R, S, T, U, A and B on the number line are such that TR is equals to RS equals to SU. This is the side which is negative side of now on the positive end, AP is equals to PQ is equals to QB. Name the rational numbers represented by. Now you have to find out how the, I mean, what, on which part it is there on the number line. So for that, what we have to do is that, now here the simplest is the extreme ends, means if you see on the negative side, T and U are the easiest part because it is already there. Now T is -1, U is -2. Similarly for the positive end, here A and B, they both are easily can be defined as A is equals to 2 and B is equals to 3. It is already. Now what you have to understand here, that R and S, and over there P and Q. Now If you look at very closely, see how many lines are drawn after t? 3, isn't it? And r is on the first position, so 1 upon 3. Are you able to understand? 1 upon 3, since it is greater than minus 1, so minus 1, 1 upon 3. And if you convert into improper form, that is minus 4 upon 3. Clear? Now look on S. Now three sections are there. Now it is on 2 upon 3. Out of the 3 part, it is on the 2. So 2 upon 3. But it is in between 3 minus 1 and 2. So minus 1, 2 upon 3. And if you convert this mixed fraction into improper, that will be minus 5 upon 3. Now look on the positive end. Now about P. Now here again the same. How many lines are drawn? 1, 2, 3. Means after A, count the lines, that is 3. P is on the first, that is 1 by 3, and Q is on the 2 by 3. Now here it is more than 2 but less than 3. So 2 will be there. So 2, 1 upon 3. So that will be that is a mixed form, and if you try to make it in a improper form, that is 3 into 2 plus 1, that is 7 upon 3. And for Q, that is 2, 2 upon 3, and I multiply it at 3 into 2 plus 2, that is 8 upon 3. Understood? That is why I picked the question from the book itself. Now question number 8. Which rational number is greater? Now for comparison, what is the prime step? We have to take the LCM of 64 and 16, that is 64 will be the LCM part. Now 64 into 1 will give you 64, so 1 will be multiplied in the numerator end. Now in the table of 16, 64 comes 4 times, so multiply 4 into 64. The answer is then try whatever will come, try to separate it and then see which number is greater. Minus, of course, will always be less than the positive number. Clear? Or what you should do is that you can use another method. If see 64 and 16, they both are somehow related to each other, because it is 16 into 4 is 16 into 4 is 64 only. So you can directly multiply over here. Leave minus 16 upon 64 and try to convert 16 into 64. So multiply both the end into 4, and you can compare it that way also. Or without comparison also, you can easily see that minus sign is there. Of course, this is always be smaller than the positive side. Arrange the following rational number in ascending and descending order. Now minus 5 upon 3 is given. Minus 5 upon 3, then 10 upon 3, then 9 upon minus 2, then 6 upon 3, and then 2 upon minus 3 is given. Now let's separate the positive rational number and negative rational number in this. So the positive rational number is 10 upon 3 and 6 upon 3. Negative rational number minus 5 upon 3, 9 upon minus 2, and 2 upon minus 3. Try to change negative denominator into positive denominator. Then 9 upon minus 2 multiply with minus 1 both the end, and it will turn into minus 9 upon 2. And for 2 upon minus 3 multiply minus 1 both the end, and turn it into numerator as a negative and denominator as positive. So minus 2 upon 3, and minus 5 upon 3 you do not have to do, because the denominator itself is a positive. Now with this, what we have to do is we will take the LCM part of all the denominators of the rational numbers, that is 6, and then try to multiply accordingly, and then after doing it, try to separate them with having a common denominator as a 6, make it as in a like fraction form. And then now here, you know it, that the biggest negative number is the smallest and the smallest negative number is the biggest. Arrange it in that column, and you know it that whatever biggest negative number will be, it will be the smallest for the positive number. Clear? With this way you try to arrange it in ascending form. That will come minus 27 upon 6 minus 10 upon 6 minus 2 upon 6, 12 upon 6 and 20 upon 6. Then make it into the simpler form, or what was been asked before, turn it in that form. Minus 9 upon 2, then minus 5 upon 3, then minus 2 upon 3, then 6 upon 3, then 10 upon 3 in a smaller sign. Now similarly, ascending order is just flip of the ascending order. So descending order is the flip of the ascending order, just so what here you will find here from the greatest to the smallest. So here the greatest is 20 upon 6, then 12 upon 6, then minus 2 upon 6, then minus 10 upon 6, and at last minus 27 upon 6. There the sign will be the greater sign will be there on each part. So 10 upon 3, 6 upon 3, minus 2 upon 3, minus 5 upon 3, minus 9 upon 3. Now question number 10. Express the following rational number as decimal. How will you make it? Now 9, 3 upon 8. Now what you do, try to turn the denominator end, that is 8, into 100. So how many times you will be multiplying, and it is not that you have to make it in 100 or only tens. You can make it in 2000 till if it is required. So try to multiply 125 on both the end. On the above, do not touch the 9. All right, just touch the 3 and 8 part, and try to convert. Now here 375 upon 1000 come. Now just simply put the dot, count the number of digits and put the dot. It will be 9.375. Easy. Now what rational number should be subtracted from minus 3 upon 7 to get 9 upon 14? Let the rational number be x, and minus 3 upon 7 minus x, because you what is the number which is subtracted. So here minus 3 upon 7 minus x is equals to 9, and the result will be 9 upon 14. What you do is try to put the x on one side so that it should turn into a positive end. Now try to put the number to the number side. Here minus 3 upon 7 minus 9 upon 40. Take the LCM of the same, and do the calculation. You will get minus 15 upon 14 is equals to x, because now you cannot further divide it. Now question number 12, find the product. Now it is in the mixed form. First try to convert into a proper form, and then try to simplify it. It is not a compulsion that you have to simplify, you have to divide the same number on the same denominator. Denominator can be of the different number as well. In terms of multiplication sign is when it is there. All right, so here 40 divided by 20, and that 20 is on the other denominator part of other rational number. So 20 divided by 20 over there. Here 19 divided by 19 into over there of the numerator end 38, where it is minus 38 divided by 19. So with this way also you can do it. There is no compulsion that we have to divide the same with the same in the terms of multiplication. Remember this. So here 2 into a minus 2 will give you minus 4. Clear? Find the value of 65 upon 10 into minus 5 upon 26 within the braces, divided by 5 upon 2. Now try to simplify this. 65 divided by 13 here, and over there 26 divided by 13, and that will give you a 5 in this side and 2 over there. And similarly with 5, here 10 divided by 5 and minus 5 divided by 5 will give you 1 over there and 2 over there. Now the 5 upon 2 into minus 1 upon 2 within the braces, because here we have to do the operation first in the within the braces and then we can open it and can do the further calculation. Now here no more further division is applied, so we just try to multiply it and open the braces. Now here minus 5 upon 4, and this divided sign, when it is removed, it will flip it. The numerator will turn into denominator and the denominator turns into numerator. And see, we further do the calculation. Now this 4 is divided by 2 and this 2 will cancel and will become 1, and here 5 will be cancelled to 5 and only minus sign will left, so minus 1 upon 2 will be the answer. Now find the reciprocal of 16 upon 49 into 42 upon 32. It is within the braces minus 1 upon 7. For this we can do the simplification as you can see on your screen. So 16 divided by 16 into, now here 32 is divided by 16 as well, and 49 can be divided by 7 and 42 can be divided by 7. After doing this division and cancellation, you will be getting 1 upon 7 into 6 upon 2. It can further divide because in the table of 2, 6 come 3 times, so 3 will be left. So 3 into 1 upon 7, that is 3 upon 7. Now remove the braces and do the subtraction part. Now 7 is both having the both common are there, so simply take 7 as a common LCM, and that will be 3 minus 1 will give you 2 upon 7. Clear? Now this answer come as the, now we have to reciprocate the number, so we have to flip it. After flipping it, the denominator will turns into numerator and numerator will turns into denominator. So this 7 as a denominator turns into numerator, and 2 as a numerator turns into denominator, that is 7 upon 2, and try to change it into a mixed form. Clear? 3 1 upon 2. The perimeter of a rectangle is 6 meter less than 3 upon 4 of the perimeter of a square. And if the perimeter of the square is 32 meter, find the length and the breadth of the rectangle, given that the breadth is 1/4 of the length. Now how to solve this part? Now here perimeter of a square is 3 upon 4 of 32 meter, and try to remove the off and multiply sign will be there and try to simplify it. The answer will be 24 meter. Now the perimeter of a rectangle is 6 meter less than the perimeter of square. So 24 is the perimeter of square and 6 meter is less, it will be becoming 18 meter. Now since you are knowing the perimeter value and you are knowing you are not knowing the exact value of the length and breadth, so for that you try to do is that let's take the length bx and breadth 1/4 of length, that is x upon 4. Now here 8 meter is equals to 18 meter is equals to 2 within the braces l plus b. Here l is x and b is x upon 4. Now try to as you can see in the calculation, now 18 meter is equals to 2 into 5x upon 4. Now do the cross product rule, try to do the cross multiplication, and 18 meter into 4 is equals to 10x. All right, Now if you find the value of x, and that is 18 into 4 upon 10, and then do the simplification part, it will be coming as 36 upon 7. Clear? 36 upon 5, sorry, 36 upon 5. So the length is been 36 upon 5, and the breadth will be 1/4 of it. Try to do the multiplication as seen in the figure. That will be 9 upon 5 meter. So the length and breadth is been calculated. Clear? Thank you for watching. I hope my video is interesting for you to understand the concept of a rational number. Thank you.